Hello guys, welcome back to my channel. I'm Shams Fatima from Sri Venkateshwara College of Engineering, Bangalore. So today I'm going to speak about cryptography. In that, we have the substitution technique. So basically, there are two basic building blocks of all the encryption technique. These are substitution and the transposition. A substitution technique is the one in which the letter of the plain text are being replaced by the other letter or by the number of symbols. The substitution technique is being divided into four techniques. These are Caesar cipher, monoalphabetic cipher, Playfair cipher, and the Hill cipher, and the polyalphabetic cipher. Now let's look into the Caesar cipher. So Caesar cipher involves replacing each of the letters of the alphabet with the letter standing three places further the alphabet. So the plain text involves meet me after the to go party. So this is nothing but the plain text, and below that we have a cipher text. So we will be defining the transposition listing. Plain text is given above and the cipher text is given below the plain text. So the algorithm can be expressed as plain text P substitution the cipher text C2. C is equal to E in the braces 3P is equal to we have P plus 3 inside the bracket mod 26. So generally Caesar algorithm is C is equal to E in the bracket K comma P is equal to P plus K in the bracket mod 26. So here are basically three important characteristics of this problem: encryption and decryption. Algorithm. So there are basically 25 key. The language are the plain text. So the text file is compressed using the algorithm called zip. So here brute force crypto analysis of the Caesar cipher is given here. So now moving ahead to the next topic, monoalphabetic cipher. It can have 25 possible key. Caesar cipher is far from the secure, so there are 26 alphabetic characters, 10 order of the magnitude greater than the key space, DES, that is nothing but the decryption. This is also called as monoalphabetic substitution cipher. So here is an example which is given as monoalphabetic substitution. So here you can have a look at the graph. The blue color represents the series 1 and the red represents the series 2 and the green represents the series 3. So here the series 1 have the highest population. Monoalphabetic cipher frequency data original alphabets. So multiple substitution known as homophones. Example, different cipher model 16, 17, 35, 25. They are homophones using rotation randomly. So let's have a look at the Playfair cipher. The multiple letter encryption is the Playfair. The Playfair algorithm is basically based on used contraction using the keyword. The keyword is equals to monarchy. Here basically monarchy is the Playfair cipher, and after that we can basically mention the normal 26 alphabets. So I and J can be kept as in one because we can replace I and J with the same keyword. The following is the rules for the Playfair. Repeating plain text letters are the same pair filtering letters. The second one, two plain text letters in the same row of the matrix are replace the letters to the right one. Top the element column circularly from the last. Playfair text is easy to break. Example, relative frequency of the occurrence of the letters. So here is a graph which represents the series here we can notice that series 3 will have the highest marking point, whereas series 1 and 2 are represented with the blue and red color, but the green color represents the series 3. So let's move ahead to the next topic, that is the Hill cipher. The multiple cipher Hill cipher is developed by the mathematician Lester Hill in the year 1929. The algorithm M plaintext, letter substitution ciphertext M, numerical value A is equal to 0, B is equal to 1 and Z is equal to 25. So here we have the alphabetical value and it is given with the numerical value from the 0. So here we have 26 alphabets, so 0 to 25. So Z is equal to 25. So C1 is equal to K11 P1 plus K12 P2 plus K13 P3 to mod 26. So similarly, C2 is equal to K21 P1 plus K22 P2 plus K23 P3 with mod 26. Similarly, with the C3, K31 P1 K32 P2 K33 P3 with mod 6. So here basically we are using the concepts of vectors using matrix. So C1, C2, C3, these are the columns, and K11, K2, K12, K13, these are the row, K21, K22, K23, similarly K31, K32, K33. So these are represented as rows. So P1, P2, P3 are represented as the plain text, so with the mod 26. So C is equal to KP, mod 26. So C and P column of the vector SAG, length 3, plaintext, ciphertext, and K represents the encryption key. So this is the example given here. The square matrix determine the matrix equal sum of all the products can be one element each column from each row on element. So here is an example of the matrix K11, K12, K21 and K22. So this represents the encryption key. Moving ahead to the next topic, polyalphabetic cipher. So general name approach is polyalphabetic substitution cipher. So it has the following feature: monoalphabetic rule is used, choose given transformation. So we have key, meet me, meet me, meet me, and the plain text is given as the following, and the ciphertext is given in below the plain text. The ciphertext row, determined column, and plain text top of the column. It is proposed to auto key system. So here is an example which represents the polyalphabetic substitution technique. This system works on binary data. The system expressed as the following: Ci Pi plus Ki, where Pi is binary digit plain text, Ki is binary digit key, Ci is binary digit ciphertext. I hope you got some information from my video. If you like my video, please do like, share, subscribe and comment. Thanks for watching my video. Have a good day.